step by step through each problem. So the first one, before we get factoring, let's go ahead and look that the degree on top is less than the degree on bottom. So that means our horizontal asymptote is y equals 0. Then let's go ahead and factor now. So factor, we have the top. The bottom factors out to be x plus 2, x minus 3. Since we can't factor anything, we have no holes. Vertical asymptote, we have 2 of them. When I set that equal to 0, we get x equals negative 2 and x equals 3. So x equals negative 2 and x equals 3 is our vertical asymptote. Our x-intercept, if I set the top part equal to 0, 3 equals 0, that is a false statement. So we have none. And a little trick now that I'm going to show you is for your y-intercept. If I plug a 0 in for all your x values in your original function, so 0 in for x, I'm going to be left with 3 over negative 6. So that is really 0, 1, negative a half. And so that's that little trick for you is take the original function. So for your y-intercept, take your original function, put zeros in for your x values, basically find your constant or left over, and that is your answer. This one, we'll start off with our horizontal asymptote. Since our degrees are the same on top and bottom, we would have y is equal to 1 over 2, because we're going to make those constants that are out in front, 1 over 2. To factor this top one, we are going to get it out to x plus 1 times x plus 2. The bottom we can factor out a 2, and then once we factor 2, that will turn into x minus 2x plus 3. So again, looking at our holes, we can't cancel anything, so we have no holes, none. Our vertical asymptotes, we are going to set these two bottom ones equal to 0. So when I set that equal to 0, that's going to give me x equals 2. Set that equal to 0, x equals negative 3. So x equals 2, x equals negative 3. Your intercepts will just be the tops set equal to 0. So top factors, there they are, equal to 0. Minus 1, so you have x equals negative 1. Subtract 2, we have x equals negative 2. So that would be negative 1, 0, and negative 2, 0. And just like the trick that I showed you on the last one, if I plug a 0 for every x value into the original function, everything that has an x attached to it will go away, and you're left with 2 over negative 12. So you get 2 over 12, which reduces to, and we'll just make that a little nicer. So 2 over 12, that will give me negative 1 over 6. And there you go. Started on this one, we have a degree, top and bottom is the same, so that is just going to be our coefficients, which would be negative 1. Factoring, we are going to factor out a negative, and then that's going to give us x plus 1, x plus 2. The bottom is going to turn into x minus 4, x plus 1. Since we have the same right here, we have whole starting at negative 1. So our new function looks like f of x equal to negative x plus 2 over x minus 4. So when I plug the negative 1 into that, I'm going to get negative 1 plus 2 over negative 1 minus 4. Negative 1 plus 2 that's going to turn into negative 1. This is going to turn into negative 5. So my whole is negative 1 and 1/5. Try to write that a little nicer. 1/5 there. Vertical asymptote, take this bottom one, set that equal to 0. So that's going to be x is equal to 4. X-intercept, take this top part, negative x plus 2 is equal to 0. Negative goes away, x plus 2 equals 0. Subtract 2 from both sides, we have x equals negative 2. So negative 2, 0. And again, my little trick that I showed you, put zeros in for all your x values up top. You're just left with 0 and negative 2 over negative 4, which is just turned into 1/2. And we have our horizontal asymptote. Degree on top, degree on bottom is the same, so that's going to be 1 over 3, so 1/3. Factoring the top, we take out an x, and we're left with x plus 1. Bottom, we can factor out a 3 first, and after we factor 3, we can factor that out to be x, whoops, try that again, x minus 3, x plus 1. We have a whole. Our whole is at negative 1, and then let's figure out the rest of it. So we are left with x on top, 3x minus 3 on bottom is our new function. So when I plug a negative 1 into the top, negative 1 over 3 times negative 1 minus 3. So that's going to turn into negative 1, negative 3 is negative 4. And multiply by 3, we get 12. Negative 12 over negative 1 will give me a positive 1/12. Okay. Then our vertical asymptote, we're going to this bottom part. We don't really care about this 3 out here. For that, and we're just going to have x is equal to positive 3. Our x-intercept is x is equal to 0. So when I plug in 0, I get 0 out. And the same thing, our little trick for our y-intercept, plug a 0 in for all our x values. So we're at 0 over negative 9, which is going to 0, 0. Nice thing about this, if x-intercept is 0, 0, your y-intercept is 0, 0. Next one, almost to the end. Degree on top and bottom are the same, so y equals negative 1. Let's go ahead and factor. So if we factor out a negative x, we're left with x plus 1. On bottom, if we factor, we have x plus 3, x plus 1. So we can cancel. So we know that our whole starts at negative 1 in our x values. So our new function factored with canceling is negative x and x plus 3. So when I plug in a negative 1, that I'm going to get negative 1 over negative 1 plus 3. So that's going to give me 1 over 2. So 1/2 is where my whole is. My vertical asymptote, I'm just going to take this right here, set it equal to 0. So that's going to be x equal to negative 3. If I set the top equal to 0, negative x equals 0, x is equal to 0. So our x-intercept is 0, 0. And again, if I plug 0 in for all the x values up top for their y-intercept, 0 divided by 3 is just 0, so 0, 0. Last and final one, our degree on top and bottom are the same, and so our coefficients negative 2 and 1. So that is going to be y is equal to negative 2. If I factor the top, I'm going to factor out a negative 2x, and then I get x minus 1, x minus 3, over x plus 2, x minus 3. So I'm going to cancel an x out, so I know one of my wholes is 0. Cancel out a x minus 3, I know my other whole is 3 something. So my new function is f of x is equal to negative 2, x minus 1 top, x plus 2 on bottom. So when I plug in a 0, so negative 2 times 0 minus 1 over 0 plus 2, that's going to be negative 2 times negative 1 over 2. Cancel, so that's just going to leave me a 1. Negative 2 times 3 minus 1, whoops, no comma there, minus 1 over 3 plus 2. So negative 2 times 2 over 5. That's just going to be -4/5. Vertical asymptote, taking that bottom, so it equal to 0, x is equal to -2. X-intercept, this top part, oops, color, take this top part, so it equal to 0, so -2x minus 1 equals 0. Divide by -2 goes away. X equals 1, so 1, 0. And then go back up to the original function. Anywhere that there's an x value, put a 0 in. So 0 divided by 0, 0 underneath is undefined, so you don't have an y-intercept. And that is it.